Hello and welcome back to geometry. I'm Mr. Gass, and what we're going to be doing today is we're going to be talking about central angles, and we're going to be talking about arcs and major arcs and semicircles. Some of these terms you might be familiar with, others are going to be new to you, and hopefully by the end of this you'll understand their definitions and you'll understand the notations for all of them. So let's get started here with our circle. So we have a circle here, circle O, centered at O, and I've drawn in the radii OA and OB. And that makes a nice angle, and that is a central angle. So a central angle is an angle whose vertex is at the center of the circle, and the sides of that angle are radii. And we measure central angles just the way we normally do. We measure them in degrees. So this central angle happens to be 81 degrees, but it could be 63 degrees, or it could be 121 degrees. It can be any angle that we would like it to be. So that's the first thing that we're going to talk about. The second thing starts with this idea of a central angle, and it's the portion of the circle, the portion of the circumference of the circle that is cut off by this central angle, and that is called a minor arc. So here we've highlighted it in orange. So this is minor arc AB. It's cut off by the central angle. And we define a minor arc as the portion of the circumference of the circle defined by 2 points on the circle. And you can think about it as the short way from A to B along the circle, because you can see there's another way to go from A to B that's the long way, but this is the short way. Measures of minor arcs are measured in degrees. And the measure of the minor arc is the same as the measure of the central angle. So the central angle measures 121 degrees. The measure of the arc is 121 degrees. Okay? If the measure of the central angle is 91 degrees, then the minor arc would be 91 degrees. We have a notation over here for minor arcs. Minor arcs are written A to B with a little arc on the top of it. And the measure of the minor arc is written like this, M of AB. And that would be equal to 91 degrees in this case. But in general, all minor arcs measure less than 180 degrees. There's one other thing, which are adjacent arcs. And we've seen that term adjacent before with the angles. And it's the same idea. So in this case, arc AB and arc AC would be adjacent because they share an endpoint A and they do not overlap. So those are adjacent arcs. One other thing that we're going to talk about is an idea of something that is called a subtending arc. So a subtending chord. So AB is a chord, and you might hear me use the term subtend from here now and then. And subtend just means the arc that is associated with the chord that's associated with arc AB. So we say that minor arc AB is subtended by chord AB, or chord AB subtends the arc. Okay, and this arc, this chord, is measured in units of length because it's a distance from A to B. So that is the straight line distance is the chord, that subtending chord, and the distance around, or the pathway around the circumference of the circle, that is the measure of the arc. Now you might be asking yourself, well, there's a distance around the circumference as well. We'll get to that in a few sections. By the way, sometimes you'll also hear people say that the central angle subtends the minor arc as well. So subtend just means to hold it. Okay? So that's a minor arc, and if you are thinking that there should be such thing as a major arc, then you are correct. So a major arc, here it is highlighted in red. A major arc is the long way from A to B. So starting from A, going through C to B. And a major arc is defined by 3 points on a circle, and we can see that when we turn on the notation here, that the major arc, if we wrote just A to B, then that would be the short way from A to B. So we say A through C to B. So ACB is the major arc. So that way we know that we're not just going A to B the short way, we're going A to B the long way. And major arcs are always going to be greater than 180 degrees. And you might notice that the minor arc and the major arc, this minor arc was 91 degrees, this major arc was 269, those add up to 360. Here it's 66 for the minor arc, it's 294 for the major arc. Again, that adds up to 360, and you might be able to figure out why that makes sense. So we generally figure out the length of a major arc, or the measure of a major arc, I should say, by figuring out the measure of the minor arc and doing 360 minus the measure of the minor arc. So that's a major arc. Now, you might be thinking to yourself, well, we know what happens when an arc is less than 180. We know what to call it when it's greater than 180. But what if it's exactly 180? Well, that's something that you have probably already seen in your experience here. And that is a semicircle. So a semicircle, if I turn everything off here, semicircle. Here it is. And a semicircle is a portion of the circumference of the circle defined by 3 points, just like a major arc. We'll talk about why in a second. And a semicircle always measures 180 degrees. So semicircle always measures 180 degrees. And you'll see, just like in the major arc, we use the notation with 3 letters here because semicircle DCE is different than semicircle DAE, because here we're talking about the semicircle that's outlined here in black versus the semicircle here that's outlined in green. So I hope that this made sense, and that if there's anything that didn't make sense, please go back and watch the video again, and pause it and take notes. So I will see you all in class. Take care, and I will see you next time. So let's see if I can pause this.